All right, hello everybody. Hope you're doing well. So I'm working on the van project, and I just wanted to kind of update my progress on my electrical system. I'm essentially rebuilding the whole thing from what it's originally. If you're just kind of tuning in, you're not familiar, I bought a Class B, which had been converted to a four-wheel drive van. And I basically gutted the interior. I did a bunch of work on the exterior, and I'm rebuilding it to put it all back together. So basically I gutted the electrical system. I've running all the wires in there for the DC. I've ran some wires for the AC system. Very simple, just 2 outlets for shore power for AC and 2 outlets which will be run off my inverter. But I'm building, this is my terminology, I call it a component system. So I'm all the individual components. And here it is. Solar charge controller, DC to DC battery charger, and an inverter. And I'll show you where this goes, but what I did is I don't know, I'll call it a cassette. I essentially built it in a tray, and this is just you guys can see it's completely removable. It's just a piece of scrap 1/2-inch plywood I had. It's essentially kind of like an L shape here. I think it's 13 inches tall and about 5 or 6 inches wide down here at the base. This will make sense in terms of where it's going to go in the van. On the back, I've got a couple magnets, and I'll show you where this goes, and that'll make sense. But let me just talk about some of the components here. I built a handful of these component systems, but every time I build them, it's kind of something new. I kind of learn. So I actually built this whole one and took it all apart and rebuilt it again because I made a few mistakes on my first time around. As I've talked about before, I'm certainly no expert on this. I'm kind of figuring out as I go. But I'll touch base on the components and maybe a few characteristics to keep in mind that I learned through my process. So this is solar charge controller. We've all seen these. This is the EP Fever Ever. I'm not sure how you pronounce it. So what this device does is the solar input. It converts it to a charge profile, which is applicable to the batteries. I'll be using some lithium iron phosphate batteries in there. This thing has a cable here, so it connects here. I fed it through the side here. And this will extend out to a portion in the van where I will be able to visually see. They call this the MT50. It's kind of like a monitoring station, but it also allows you to do some programming on this. So I had to program this to charge properly for the lithium iron phosphate. My point to all of you, and I'm sure many of you guys are very well familiar with this, but different battery types require different kinds of charge profiles to charge appropriately. So it's important that if you guys buy a solar charge controller, whatever brand, that you ensure that it accepts, almost all of them will charge sealed AGM, lead acid batteries. But, the lithium ion, the price of, there's a lot of significant advantages to lithium or lithium iron phosphate batteries. So in my opinion, if you buy a solar charge controller, even if you just have a sealed battery or an AGM battery, it's probably a good idea to buy one that you can charge lithium iron phosphate batteries on, because it's probably very likely that you would upgrade at one time, or it's at least nice to have that opportunity. So I'm using lithium iron phosphate. This one has that capability. And you use that MT50 to program it, but this MT50 will also give you some sense of your current voltage and your input and output wattage. So, but it has a remote connection for that little monitoring device. So I got that in place. DC to DC battery charger. I'm sure there's other brands. The Renogy brand tends to be the one that's most common out there. So what this does is it does a couple things. So your alternator in your vehicle, which is basically a small generator that every vehicle has to keep the starter battery, which is the battery that you use to run the electronics in your vehicle and start it, keeps it charged. In a lot of RVs or vans, or of course you can add it to any vehicle you want, you can tap some of that energy produced by the alternator and use it to charge up your batteries. And it's a nice redundancy to solar, in my opinion. Now, some RVs and some vehicles only have this, and they don't have solar. I like the fact of having both, and I really like solar. But it is a nice redundancy. So what this means is this device, and I'll explain how it hooks up here. When you're driving your vehicle, it will actually charge the batteries of your whatever vehicle you have. So in my case, a van. Now, one thing to consider is most starter batteries, which is the battery that's in your vehicle, are AGM or what they call sealed, but they're basically a lead acid chemistry. Like they talked about this one, I'm using a lithium iron phosphate battery, which is a different chemistry. It's a different kind of battery. And the charge profile, which means that the way in which the battery is charged is significantly different. So to avoid damaging your battery and to charge it appropriately, you have to make sure pretty much any time that you're going to input energy into your battery to charge it, you have to run it through some kind of a device which is going to convert it to the appropriate charge profile. This DC to DC battery charger does the same thing. So up here, let me show you real quick here. Now this one, as opposed to the this solar charge controller where you actually, programming is kind of a little bit of a strong word, but where you set the settings through the MT50, or you could plug it in your computer if you wanted. This one uses a very simple toggle system, okay? So if you look right here, there's a few little switch toggles. The instructions for this DC-to-DC charge controller give you all the different parameters. So this thing can be set up to charge AGM sealed batteries, but it could also be set up to charge different kinds of lithium or lithium iron phosphate batteries. Anytime that you get a battery, specifically as I've seen in the lithiums or the lithium iron phosphate, is they're going to have an information card that's going to have the various parameters. So in the instructions for this DC to DC charge controller, let's see real quick here if I can find it. It gives you right here. It gives you some parameters to where you basically switch. This is divided into 5 different switches, and you turn them on or off depending on the exact profile of your battery. My point being is it's important for you to look at that and go into those. There's other brands of these. They may or may not use toggles, but the long-winded point is make sure that you set it up appropriately to charge your batteries. And then finally, over here, we have the inverter, okay? And the inverter is, it doesn't have anything to do with recharging your batteries, but it is important because this device will convert the direct current, which is the form of electrical energy that's released from any kind of a battery, into alternating current that can be used for household appliances. Now, in my camper van and all of my previous campers, and I would imagine most of you in your RVs and other campers that you have, in the small confined system of an RV or a camper, using DC to run various appliances typically is more efficient. However, so for example, the 5,000 BTU AC unit that I use, that runs off of alternating current and does not have a DC current option. So it's pretty important to include some form of an inverter into your build so that you can transfer the DC current produced by your battery into alternating current, which will allow you to run a lot of devices which we typically recognize as being run by that you would run in your house, for example. So, the standard 3-prong plug-in. So this tray or cassette, whatever you want to call it, Those are the three devices. It's kind of, in my view, it's kind of the heart of the electrical system. However, it's certainly not the entirety of the electrical system, because you have a battery, and then of course you have, the extension of all the various wires and connection points between the various devices that you're going to use in your van. But now, a lot of you guys might be looking at this, and this looks like a big wire nest. Some of you might look at it and say it looks very neat. That's all personal position. I will admit, to have this many devices in this small of an area, it is pretty tight. Though this, again, to some of you might look chaotic, and to some of you this might look very neat. This is a pretty tight, confined area to have all these various wires connecting all these various devices. But as you guys will see where I place this in the van, it was important to me to be able to fit all this in a small, confined area. So what we have in here is, and this is my personal opinion, there may be different opinions out there if this is appropriate or not, but having circuit protection in the various connections of all these devices is incredibly important. And I guess my point to you guys is, if you assemble your own system, however you do, it's important that you have devices like fuses or breakers, because when you're messing with electrical, it can be very dangerous, particularly if you get short circuits, okay? Because what can happen is, if you get a short circuit, meaning the circuit closes without running through some sort of device that creates resistance within the circuit, it can draw a lot of currents rapidly, and it can melt wires and create fires. So circuit protection, whether it be breakers, such as in this case, or a fuse, such as in this case for solar, is very important, because if you were to ever generate a short circuit, those devices protect the system. They're rated typically in amps, and they will pop or break to prevent any kinds of fires. So whenever you build these systems, it's very important for you to be very thoughtful. My purpose of this video is not necessarily to go into very finite specifics of how to build these systems. There's many other YouTube channels and so forth, and wiring diagrams that you can find online that do a really good job on those. In fact, I used a wiring diagram produced by a guy named Will Prowse, who has a very popular YouTube channel, to build mine, and I would recommend. He is a great source for information. So if you want detailed information on how to build your own component system, I would highly recommend that you go to him. But I'm just touching on a couple features, and the way that I built this and the way it inserts in the van, I think, is relatively unique, and I think some of you guys might like it without getting into the detail of the system. But I'll touch base on a few minor things here. So back to this DC to DC converter here. So not only does it take the current produced by your alternator of your car and transform it into an appropriate charge profile to charge your battery. Sorry about that. But what it also does is it has a device built into it called an isolator. Okay. If you're gonna tie in an electrical system into your starter battery of your vehicle, it's very important that you have this device called an isolator. And what an isolator does is it isolates the house battery system, meaning the battery that you use to power your camper section of whatever kind of vehicle you're working on, a van, RV, truck, camper, etc. So it separates that battery and all of those electronic devices from the starter battery of your vehicle. And that's very important because of this. Let's say, so I was talking to a friend of mine recently, and he has a converted, I think it was like a passenger van to an RV. It was like a bigger one, like you would transport multiple passengers in. And his water pump was running continuously. He had some sort of fault. If the house battery, or the battery system that tied in the camper portion, was connected to his vehicle, but he didn't have any kind of isolating mechanism, because you got a fault in that water pump is running continuously, what it could do is it could actually tap energy from the starter battery of the vehicle and draw energy from that starter battery to the point where that battery goes dead. And that would create a problem, because when you went to get in your vehicle and start it up, you wouldn't have any energy to start the starter motor of your vehicle. And even though, you know, like those kinds of faults can occur. You know, it could just be as simple as if you had an RV and you're running your fridge in the RV and you didn't jump in your RV for a couple days, which is obviously very common. It could draw down the starter battery in your vehicle. That's not good for the battery, but it's also not good in the sense that it could produce a scenario where you're not able to start your vehicle. So having a mechanism to isolate your electrical system in your camper from your starter battery of your car is incredibly important when it's tied together via a mechanism to use the alternator of the vehicle to charge the battery. And an isolator, in all of the circumstances that I'm aware of, is essentially a relay. So it just relies upon a small amount of electricity in a certain set of parameters to open up a connection which allows the connection between both devices. So this wire that you see right here on this particular one, and it may be different on different brands, they label this as what's called a D+ battery. And what you do is you tap this into the starter or the ignition on circuit for your vehicle, and that opens up a relay which exists in here. So what that means is if your vehicle is not in the on position, there is no way or basically that the house battery system is completely disconnected from the starter battery system in your car. So as you guys will see when I walk over to the van and show you where this thing inserts, this cable is connected all the way through to the back of the van, and what it does is that when you switch the ignition to the on position, it will send electricity or a current to this point, which will open up a breaker in here and allow the two systems to connect. But because it's in the on position, the assumption is that the vehicle is running, or at least you wouldn't leave it in the on position continuously. So therefore, it separates the system at a particular time and place. Now, isolators can be a separate device, which can bolt up at different portions of a vehicle, or it can be built into a device such as this DC converter. Before we walk over and install this in the van, let me show you guys one more way in which I'm connecting these. Okay, so as you guys will see, this is meant to be a removable platform. That way you can easily service all these devices if any of them fail or you want to make any corrections to it. So when we go to put this in the van, I created various connection points here, right here, so where you can remove this and then you can just connect it in place. So we have an MC4 connector for the input, both negative and positive, of the solar charge controller. Right here, what I'm touching right here is the input for the DC to DC battery charger. Basically, you'll see I have another connection that has a loop here, and I will basically bolt them together, and I'll wrap it in an insulating black electrical tape just to avoid any connections. Now, this is not necessarily specialist design, but of course these are the positive and negative of the battery terminals. And then this little wire that's hanging here, and you guys will see this connect, this is for the power source for the isolator that is built into the DC-DC charge controller. Additionally, and this may not apply in all circumstances, but sorry guys. Sorry, I'm using my little tripod there. All right, there we go. And you guys will see where this connection right here is for a chassis ground, because I'm using a van. And that's important because that's going to complete the loop for the DC to DC charge controller right here. But it also, I've grounded both the inverter and the solar charge controller, which if you have a applicable scenario, it is important to do that. So let's walk over to the van and see how this all plugs in. Okay, guys. So this is the back of the van. These are the two doors right here. And this is a couple significant things going on right here. So this opening right here is where I will slide my lithium iron phosphate batteries. So there will be two 200 amp hour batteries for a total capacity of 400 amp hours, which will slide into that area. This little section, let me make sure it shows up right here. Right here is where that cassette with all of those devices that I just talked about will slide into. This portion right here is what the housing was for where the generator will be. It's, as a side note, it's now a section where I will store other goods because I got rid of the generator. But this is a metal, or it's a steel, so it's magnetic. So those magnets, when I slide that in, they will snap against there. And as you guys can see, that's a relatively tight and confined space that I had to use. This top right here, it's not on there now, but it will be attached with a piano hinge. So I will be able to slide this open if I want to service it while it's in place. But of course, since it's only mounted via magnets and those relatively easily disconnectable connection points, I will be able to remove it if I need to change a device or service something. This wall right here will be open when this is in place, but ahead of that, kind of where you see that board right there, ahead of that will be areas which will be cosmetically viewable from the inside of the van, and that will be sheathed in cedar, so there will be some limited access. Not the point of our conversation here for this video, but this device right there that you see attached to that wall, this is the fuse block which runs all of the various DC things. So let me, I'll go into a time lapse, but I'll show you how I slide that cassette into place. Okay, so as you guys can see now, is that cassette, or that box that I built with all those electronic devices, is slipped into this space, and it's held magnetically to this wall. And the magnets are very strong, so I don't have any concerns about that breaking apart. We have our two battery cables, which will extend into this region. We have our AC plug-in, which connects up into this upper box here, which is a GFCI. And this fits through this hole right here and connects into one of the AC outlets, which is positioned on the inverter. Okay, right here we have our two inlets. So we have our negative for our negative AC input. We'll connect that. And we have our positive for the positive side of the AC input. This right here is the connection point for the DC-to-DC charge controller. I don't have a bolt with me, but I will run a bolt through it and connect it right here, and then I will wrap that in some electrical tape. And then finally, that DC-to-DC charge controller, the positive battery section to operate that inverter. I broke it off when I was inserting it, and I grabbed the wrong connection, but basically it will connect right here. Okay, now later, once I know for sure I got all the wires, I will wrap all of this with a conduit and make it look nice and neat. But my point to you guys is this is a nice system because it's compact. Okay, it doesn't take up a lot of space. It's easily removable if you need to service it. And then, of course, the connection points are also very easy. In the far back there, which you guys cannot see, I have a connection point for the chassis ground. And then in the far, let's see if we can show it here. This is not super important for our point, but kind of more toward the inside of the camper, I have a wall section which will be kind of universally acceptable to all portions. And that is where that MT50 and the remote on and off switch for the inverter, which I forgot to talk about, will connect into that point. So anyways, guys, my point of this video, though, is just to kind of give you some idea of the various components that you'd use in a component system and my solution to mounting the component system in the van in a way that makes it easily removable and serviceable, and it's also simultaneously compact. Now, one thing to keep in mind that if you guys build a system like this, right now we're rolling into winter, so I have less concerns about heat. But when we roll into the summertime, or perhaps even in the wintertime, if you're really working the inverter in particular, there is a lot of heat generation. And there, like I said, there will be a wall up in the upper portion. So I will mount a fan in there, which allows the circulation of air to kind of help regulate the temperature and keep all these electronic components cooler. And I might even go as far as hooking up a thermo-electronic switch, which basically is an electronic switch which at a certain temperature would be activated, so the fan would come on automatically on its own. So I hope this was, it's not a complete video for building your own component system. There's many other better resources for the specifics, but I hope in an overview, this guy gives you guys a good idea of the kinds of things that would be important if you built your own system. So thanks for watching.